Wow.
Mr. Graham!
What?
Wow.
What a great start to a Monday. Black.
Wish it was a Sunday.
Lesson 14.b. This talking about angles of elevation and depression. Put your hand out horizontally. Thank you. Okay? Horizontal, right? Now, if I talk about, now what angle would this be?
90. 180.
Relative to the ground?
90. 100.
I got my hands on the camera.
Zero.
Come on, wow.
0 degrees. Perfectly horizontal is 0 degrees. Now, if I talk about an angle of elevation, what direction do you think I'm going? Elevation, right? So an angle of elevation is the angle that from horizontal up to whatever it is that you're doing it. Try not to just do this with the camera. Okay?
I'll try.
All right. So where this idea comes into play, let's take example 14.3. A man 6 feet tall is 200 feet from a tree, and he measures the angle of elevation to the top of the tree as 11 degrees. How tall is the tree?
11 degrees.
11 degrees tall.
Thanks for playing. Okay, let's say we've got a guy. Here's my fabulous art skills here. This guy
They're great.
is 6 feet tall.
6
6 feet tall. And he's looking at a tree. Yeah, I teach math, not art. It's like broccoli.
Hey,
Let's get a good shot of that.
Alright.
left leg.
Woo-hee.
Yeah, he needs to get to the hospital. But in the meantime, he's looking at a tree.
This guy would not be happy with you.
Don't.
Alright, so there's a tree here.
Okay, that tree's supposed to be 250 feet.
Wow. No.
That guy's
Okay.
tall.
Obviously,
All right,
this is not to scale.
Yes, obviously this is not to scale. Alright, so here's the ground. The distance from the guy to the tree is 200 feet. And pretend that the eyes are on the top of his head. He is looking at the top of the tree, and the angle of elevation is 11 degrees.
11.
Wow. So what we want to know is, how tall is the tree?
That's an 11
No.
for the viewers at home.
Question?
No, I was just so happy.
Instinctive hand raising?
Yeah. I was just like, woo! Gotta put it up. It's like roller coaster in here.
It's like you're in church and you're preaching. Something like that?
Oh yeah.
So we want to know the height of the tree.
That's nice.
Yes. Isn't that nice?
It's only 6 feet tall.
Alright, so what are we so since this is trigonometry, what shape do you think I should draw?
A triangle.
Triangle.
That'd be so stinky.
Alright, so let's draw our triangle. Let's draw the triangle here.
Okay.
We have 11 degrees here because that's the angle of elevation.
200.
The distance from here to here is 200 feet.
Feet.
And we are looking for this right here. What letter should I use?
11.
X. X.
And,
X.
and
Let's use a name.
X.
Let's use a name.
How about T for tree?
How about
Actually, no.
How about
X for Excalibur.
Xavier?
Let's use a name.
Fine, X. No imagination.
I said Excalibur.
Okay, how are we going to find
X for
X?
X.
What relationship do we need? Sine, cosine, or tangent?
tangent.
Yes.
I don't know, I have to look.
Side.
No, opposite. Opposite. Opposite.
We have the opposite.
Opposite.
We're looking for the opposite. We have the
Tan.
tangent. What is the relationship?
That.
Opposite over here.
Tangent of what equals what over what?
Change, change.
Opposite.
The angle always goes here. Right? So the tangent of 11 degrees is the opposite, which is... Oh, okay, hold on. The opposite is
X.
X.
200.
200.
Now, I suggest you do it this way. Just put a 1 here and cross multiply.
Bro.
So 1 times X is X equals 200
like
times the
40,
tangent
40,
of 11 degrees.
7.
Launch calculators, what's X?
Oh, wait, let me do it.
Something that's really big.
38. But they asked for how tall the tree was. You gotta add 6 feet
yeah,
to
we're
it.
getting there. We're getting there. Calm down.
It's the answer's
38.87.
38.8.
I got this.
Bless you.
You're at 38.88.
That's wrong.
No, it's not. You want to bet?
So are we done?
No.
Because the question is, how tall is the tree? We just found this much.
Plus 6 feet.
Here in Alabama, it's really hard to
We
find
need
a
to
tree
add-
that small.
Okay. I know it's Monday, but try to control yourself a little bit, please. So 38.88 feet is this distance. The height of the tree, we need to get the other 6 feet here. Right? We gotta add those 6 feet to what we just found, and obviously that is not to scale. And we got about 44.88 feet. Don't forget the units, because this is a problem that has to do with units.
What?
Okay. Now the other side of angle of elevation, right? If this is 0 degrees horizontal, if we are looking up, that's an angle of elevation. What do you suppose? We have to have something for going down, right?
Inclination.
That's called an angle of depression.
Oh, it's depressing.
I know, it's very depressing.
You could just say
It's
decline.
depressing.
Because
So your eyes just went down.
at the gym, you would say, let's do some.
Okay.
Depression.
Let's
Blue? No, pink.
Oh, I get it, because depression brings you down.
Exactly.
Go.
Yeah.
Ooh.
Go.
Way to piece it together, Bob.
That's why they call me
Alright,
Chuck Norris.
example 14.4. We have an airplane flying at an altitude of 3,000 feet above the ground. Airplane.
Hey, that's not.
Ooh!
It looks like I worked out a head.
That's so disappointing.
And,
Please add a cockpit.
and we are 3,000 feet above the ground. 3,000 feet above the ground. The pilot, guy sitting right here,
The cockpit.
yep,
And
right
the
there, guy
cockpit.
sitting right there, sights an object on the ground. So he
It's an
sees
alien.
something on the ground at an angle of
That's good
depression of 26 degrees.
Whoa. He has a good vision. 300.
It could be a bus, for all we know. Okay, so if this is horizontal and it's an angle of depression, that means he's looking down at an angle. He's looking down and he sees something on the ground at an
The way
angle,
out.
angle of depression of 26 degrees. And the question is, what is the slant range from the airplane to the object? Slant range is going to be what?
26. No.
What's it asking for?
That if that's 90, then that would be.
It's asking for the slant range. It's asking for this distance.
Yeah.
And black needs to be replaced.
It's wood that way.
Thanks,
Okay.
man.
Your
Whatever.
pen broke.
Okay. Use this one.
I bet that looked cool on the camera.
Alright, so we are looking for the slant range. I'll call this S. How are we going to find this? We need to draw a triangle, right?
You already drew one.
Okay. Now there's technically two ways to do this. I could use this triangle, or I could use this triangle.
90 minus 26.
I would recommend this one.
Yeah.
And let's see, so 3,000 feet above the ground. Alright, so what's this side?
Read that.
What's this?
Nothing.
We don't know. What's this?
Yes.
Okay, that's what we're looking for. This is our S. And what's this angle up here?
64.
What? 64 degrees.
Si,
Right?
senor.
This angle here is 26, but this is the one in our triangle. So we have to do 90 degrees minus the 26 leaves how much here? 64.
Wait, would it be cosine?
So which sides do we know?
Opposite.
Adjacent and not by.
Okay, well, the angle, Alright, which two sides do we know?
Adjacent and hypotenuse.
We know the adjacent and the hypotenuse. Which relationship is that?
Cosine.
Cosine.
I was right. Woo!
So cosine of how many? Cosine of what? Angle 64 degrees equals adjacent over hypotenuse.
Yes.
I recommend you put this over 1, cross multiply, and here's an example of why I recommend you do it this way. Because if you get into the habit of saying that your variable equals whatever the number is times the trig function of the angle, sometimes, like in this one, what's going to happen here? 1 times 3,000 equals s times the cosine of 64 degrees. So when I solve for s, I got to divide both sides by cosine of 64. Cancel, cancel. So s is actually 3,000 divided by the cosine of 64 degrees. That's why I recommend you do it this way.
Oh no.
Put it over 1 and cross multiply so that you know whether you need to multiply or divide.
Fine.
So be careful. So what does this come out to?
How much?
Calculate it.
Six thousand
Calculate
eight
it.
hundred forty-three
Backpack.
point 52.
Great job.
What do you got? Say it again.
6,843.52.
Yes. Am I done?
No.
What are you doing
Wait,
for rubber?
yes.
Leave some rubber bands alone. That's feet. Make sure you answer. On the word problems, make sure that you have the units in there. Stop messing around with rubber bands. I hope you hurt yourself. Is it on video?
Yeah.
Excellent. Looking forward to watching that part.
It happens exactly at 12:12.
Thank you.
Whoa.
So, quick recap. 0 degrees, if it's angle of elevation, we are looking up. If it's angle of depression, we're looking down.
Down.
And make sure, technically, it's not a requirement that you draw a picture, but it's a really, 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 really good idea to make sure that you know what's going on, especially in a problem like this. It gave you the angle of depression. If you use this triangle, you have to subtract this from 90 to get this angle right here of 64 degrees. Because the other way to do this, let's see this. Now the other way we could have done this one is if we did this triangle here, this would be 26 degrees. What's this?
Nothing.
We don't know. Do we care?
No.
What this would be our S, and this would be 3,000. What's our relationship here?
Opposite over
We've
hypotenuse.
got opposite and hypotenuse, which is sine.
Yeah.
So if we do sine of 26 degrees equals the opposite over hypotenuse, put this over 1, cross multiply. Now we have 3,000 equals S times the sine of 26 degrees. Divide both sides by sine 26. And if you do 3,000 divided by the sine of 26 degrees, you should end up with the same answer. But notice you have to be consistent. If you're going to use the 26 degree angle, you have to set it up like this, and you end up using sine. That's why you need to. You really have to draw the shape so you know what you're doing. And that's angle of elevation, angle of depression, and we're done with this video.
Fine. Ba, 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 ba.